Welcome to Learn with Us. This is the 12th practical of Basic Electronics.
What is the objective of this practical? The objective of this practical is to obtain the characteristics of light emitting diode. Now, what is a light emitting diode or LED? LED is a semiconductor junction diode which emits light when current passes through it in forward biased condition. When the device is forward biased, electrons cross the p-n junction from the p-type material, and these electrons recombine with holes in the p-type material, as you can see in this figure. These free electrons are in the conduction band and they are at a higher energy than the holes in the valence band. The difference in energy between the electrons and the holes corresponds to the energy of visible light as shown in this figure. When recombination takes place, the recombining electrons, they release energy in the form of photons. The emitted light tends to be monochromatic, means one color, that depends on the band gap and some other factors. Now we will talk about LED semiconductor materials. Light emitting diodes are made from compounds of group 3 and group 5 elements. The wavelength of light generated by the LED depends on the band gap energy and doping level of elements. Some LEDs emit photons that are not part of the visible spectrum, but they have longer wavelengths and they are in the infrared portion of the spectrum. Photon energy is related to the emitted frequency by this relation, where E is photon's energy, H is Planck's constant, C is the velocity of the light, and lambda is the wavelength of the emitted light. Now we will understand the symbol of a light emitting diode. Look at this figure. A light emitting diode has a positive, that is anode lead, and a negative, that is cathode lead. As you can see, the schematic symbol of the light emitting diode is similar to the diode except for two arrows that are pointing outwards. The anode is marked with a triangle and the cathode is marked with a line. The longer lead of a light emitting diode is almost always the positive, that is anode lead, while the shorter one is the negative, that is cathode lead. So this is how you are going to identify the terminals of a light emitting diode. Now we will talk about the current voltage characteristic curve of light emitting diodes. Look at this figure. This figure shows the curves of different LEDs. LEDs are diodes whose PN junctions behave in a non-linear fashion. Very little current flows until the forward voltage is reached. Above this value, the current increases exponentially with an increase in voltage. LEDs, like all diodes, conduct in one direction and they do not conduct in the opposite direction. These IV curves are useful for estimating the current that will flow at particular voltages and for calculating resistor values as well. Now here is your lab activity. Connect the components on breadboard as per this circuit diagram. Then connect the power supply and increase voltage from the power supply from 0 volts to 15 volts in steps. Then connect the voltmeter and ammeter with the LED. Then measure voltage across LED and current through the LED. Note down the readings in the observation table and also observe the light coming from LED. Then draw current voltage characteristic curve for forward biased condition. So this is your lab activity. Here we have your post lab tasks. The first question is, what are the applications of light emitting diodes? The second question is, on which factors the wavelength of the emitted light depends? The third question is, what is the significance of current voltage characteristic curve? And the fourth question is, which parameter controls the brightness of light emitting diodes? You have to answer all these questions.
Thank you for watching this video. If you have any questions, then write your questions in comment section of this video. Don't forget to subscribe our channel and share it with your friends and family. Thank you.